Hello everyone. Today in this tutorial we are going to study about how to perform a regression analysis in STATA and the regression analysis of panel data. So for panel data, the most important regression analysis which is commonly done is fixed effects or random effects, and you have to choose between these two based on the HAUSMAN test. And today we are going to conduct these tests in STATA. First of all, let me introduce you with the data. We have got cross-sectional data of countries. There are so many countries, around 56 countries are here, and this is an econometric type of data in which year and the income group, FDI, and there are so many variables here. So before going into the test formally, and your data should be set as per panel data. For that you have to generate first an ID variable, and in that ID variable you have to give an ID to every country which you are using. Like this, you can see in my ID, number 1 is given for one country, and then number 2 is for second, like this. So all 56 countries have been given an ID, and then you have to declare the year, that your timeline from 2001 to 2019. So this activity you have to do it before your formal analysis. And after setting your data as panel data, what you have to do is, first usually you do your correlation analysis, right, to know that whether your variables are correlated with each other or no. So for that purpose you can type the command as well here in this command list, but you can also do it from the drop down list over here. So this is the statistics, and here summaries, tables, in the test you should go to the descriptive statistics, and within the descriptive statistics you can see here correlations, right? So this is partial correlations and this is pairwise correlations. So you have to select this option, and then here variables, you can select all the variables. Like my variables have already been selected here. These are the variables. The first one is my dependent variable, and all others are independent variables. And you can select from this drop down menu, right, whatever variable you want to select. Then here are some of the options which you can check, like print number of observations for each entry. So if you check this one, then with every entry the number of observations will also be recorded, but I don't want that. And print significance level of each entry. So this will print that how much is the significance level. If you want it, you can check it, or if you don't want, you don't have to check it. So like this here, the option is selected significance level for display of coefficients. So if you want that your coefficients are 10% significant, then it should be displayed. So I don't want that. I want my all the coefficients to be displayed, otherwise some of them will be missing. So I've unchecked it. And significance level for displaying with a star. So here also you have an option whether you want significance level for 5% or 10%. That means 90% or 95% significance level. So I did it 10%. So now, or maybe you can do just 5 as well, and then you should just click OK, right? So this one is my table here. So first you can see this is negatively associated, and the star here, it shows that its significance level, and 0.000, right? So all these are mentioned here. Whatever is 0.05, lower than 0.05, has been given a star here. So this is how you have to do your correlation analysis. So and then when you observe that how your variables are correlated with each other, you can just copy it from here, right? This table you can copy and then paste it somewhere else, wherever you want. Now the next one is the test, right? So what test we want? First is the fixed effect. We should check the fixed effect. So for fixed effect, the command here would be xtreg, right? And then first is a dependent variable and all other independent variables, and at the end we don't need this significance and all this. You have to write fe, right? So now you have to do it like enter. So this is the result for my fixed effect, in which I can see that the number of observations, all the details, the r square within 0.21 and between 0.02, and f statistics is significant. It shows that my model is significant. This is the p-value, and all the variables are shown already here. Okay, so there are many variables which are significant, so I don't go into the details, but first what you have to do is now you have to store these estimates. So you have to write store estimates, estimate, store, store fe, right? So we stored these fixed effect estimates over here, and in the same way we have to conduct another test for random effect. So for random effect we need to write here, in place of fe we have to write random effect. The rest of the equation will remain the same. And now we can see here that in random effect we have got a different set of p-values. In previous one, in fixed effect, the first one variable was not significant, whereas here this variable is significant. So there is some changes in variable significance level, and this one is also probability. You can see 0.000, so that means that this model is also significant. So now you have to store these estimates as well. So estimate, store, store, re, random effect. Oh, spelling mistake. Estimate, store, store, re. So we stored these two estimates, and now we check HAUSMAN test, HAUSMAN, HAUSMAN, between FE and RE. So you can see here that this is the HAUSMAN test, and in this HAUSMAN test the results are probability is 0.000. That means that this probability is significant. So when this probability is significant, that means we should use fixed effect in our model. So here the hypothesis is, null hypothesis is, difference in coefficient is not symmetric. So if it's significant, that means that we have to reject the null hypothesis, and this says that random effect is the random regression model RE should be used. Random effect regression model should be used. So when it is significant, then that means we have to reject the null hypothesis. That means that the random effect is not a suitable option for us, and we should use the fixed effect model over here. So guys, this was a quick overview about the panel data analysis in STATA, and how to do first do the between the fixed effect and then random effect, then choose between them and do the correlation analysis among your variables. And if you want some of other commands, like if you have some interaction terms in your model, so let me explain those to you as well. For example, if you want some interactions, so I apply the fixed effect, and if I want, for example, the interaction between MXP and PC income, so the command for this is you have to just type a hash, right? If you type a hash between these two, so then it means that it will give you an interaction effect in your model, right? Okay, so for that you have to put it like C, right? So it has to be C dot with whenever there is an interaction term, you should type C, because it has to be a continuous variable. Yeah. Now it's here, so you can see first we saw the interaction M export and PC income. Out of these we interacted these two variables, and the interaction term is significant here. Rest all other variables are here, and here you can see that these two M export and PC income, these two are represented here just as interaction term, and they have not been included in the regression analysis with LFDI, the dependent variable. So well, if you want that as well, then you have to just do put one more hash, double hash, right? So here we put double hash between these two variables, but keep this thing in mind, that you should put a .c dot before both of the variables to declare that these are continuous variables. Otherwise this interaction term won't work. So now let's see. Yeah, now you see, because of this hash twice, putting the hash twice, now first we have MXP individually with LFDI, it's a significant, and PC income is also individually regressed with LFDI, and it's also significant. And in the next step, both of these terms have been they have been multiplied with each other, or the interaction term has been conducted here, and it's also significant. So guys, I told you about one more command, and this is the command for interaction term. It's a very quick, and helpful command, and I think it's not available in older versions of STATA. Mine one is STATA 13, so it's available in 13. Thank you very much for being with us, and if you like this video, please hit the like button.